Next concept is for loop. That is basically an example of the structure that is count control repetition structures. So for loop will repeat for a specific number of times, or otherwise count control loop will execute or iterate for a specific number of times. For example, in this case, we are using a for loop. So use a for statement to write the count control loop. And the syntax is for variable n. You are creating an array basically, and then you are having all your items or values. So that is for variables in value 1, value 2, etc. And then the statements. The variable here, which is used in the first statement of initialization of the for block, is called as the target statement. Sorry, target variable. So this is a target variable which will be assigned to each and every value when you are executing the loop. So once I'll show you an example, it will be much easier to understand as well. So yeah, you are creating a sequence of items, and for each and every iteration, like for example, for the first execution or iteration, the variable will be value 1. Next, for the second iteration, the variable will be value 2. Third iteration, the variable will be value 3. Fourth variable will be value 4, so on and so forth. So let's take a look at this example here. No. So you are displaying the numbers from 1 through 5. So for num, which is our target variable, which is also short for number, in the sequence 1, 2, 3, 4, 5, colon, print num. So for the first iteration, the num value is 1. For the second iteration, the num value is 2. That is the reason why you see 2 here. For the third iteration, the num value is 3. You see number 3 as your output. For the fourth iteration, num value is 4. For the fifth iteration, num value is 5. That is the reason why you'll see the numbers 1, 2, 3, 4, 5 displayed in the output. And also notice the print statement after each and every execution, the output will be printed in the next line. So it is automatically having a next line assigned to it. So as I've mentioned, first iteration num is equal to 1, and the next or the only statement in the block is print num, right? As num is 1, you're printing number 1. Second iteration num is 2, you're printing 2. Third iteration num is 3, you're printing 3. Fourth iteration num is 4, printing 4. Fifth iteration num is 5, printing 5. So as there are no more values to assign after number 5, the loop will be automatically exited. So in this case, like in for loop, you do not need a sentinel to make this condition false, because you're basically not testing the condition. You are taking the value, substituting that with the values that are assigned in the sequence to the target variable, and then you are executing or you're changing the values for the target variable for every iteration. Okay. So here is another example. Like if you want to display odd numbers from 1 through 9, so you have 1, 3, 5, 7, 9 as your sequence, and then first statement, first iteration, num value is 1. So use the output 1. Second, it will be 3. Third, it will be 5. Fourth, it will be 7. 5, it will be 9. And this is for the numbers, but when you are working with strings as well, that is the same thing. So you will be declaring the strings inside the quotes, right? We already know that. So for name in the sequence of strings, which is winken, blink, and nod, when you print name, for the first iteration, you'll see the output as winken. Second is blinken. Third is nod. So we can also use range functions. These are particularly important. Like let's say in this example, you're only printing odd numbers from 1 through 9. What if you want to print all the numbers from 1 through 100? Then you cannot just write 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth till 100 in a sequence, right? So that is the reason we are having range function. So you can use the range function, which is basically used to simplify the process of writing for a for loop. So this can have 1, 2, or 3 arguments. So one argument is like when you only have one argument inside the function, that is, let's say, range of 5, that 5 is used as the ending limit. So you will see the values 0, 1, 2, 3, 4, which are before 5 as your outputs. 2 arguments, the starting value will be the starting limit and the second value will be the ending limit. And you have to remember that the second limit is not included when you are having 2 arguments. Same thing. With the 3 arguments, the third argument is considered as the step value. So let's say you want to print all the odd numbers from 1 through 100. Then instead of writing just the odd numbers, you can have the first argument as range bracket 1, comma, you wanted the 100 to be included as well, right? So that is the reason you will add +1 to your ending limit, 101, comma, 1 will be the step value. So first limit is 1. And as you are adding the step value that is 1, it'll do 1 plus 1, it will skip the second one, it will print 3. So we'll see the examples. So let's take a look at this. So it is range of 5. Also notice this will return the values in sequences. So it will contain a sequence of values, but that will basically return a value in the format of sequence. So for X in range 5, that means, like, just the output of range 5 is 0, 1, 2, 3, and 4. Okay. So it will give you a sequence with like square brackets, 0, 1, 2, 3, 4. 5 is not included. As we have 0, 1, 2, 3, 4. That is 5 numbers, and we want this to be printed for 5 times. So that is the reason you are using range of 5 as your argument. This is single limit or single argument example. So for the first iteration, the value of X will be 0. If someone has guessed it, that is right. X is equal to 0. Second iteration, the value of X will be 1. Third iteration, the value of X will be 2. Fourth iteration, the value of X will be 3. And for the fifth iteration, the value of X will be 4. 0, 1, 2, 3, 4. Same thing, like here is an example with 2 arguments. The first is the starting limit. The second argument is your ending limit. So what are the possible values from this function? Just for the range function, you will see in the numbers 1, 2, 3, and 4, right? Because the second limit is not included. So when you have print num, so the code will display 1, 2, 3, 4 as your output. Next, for num in range 1, 10, 2, you have the step value as 2 in this case. So you have the first argument, that is 1, which is the starting limit, 10 as your second limit, which is not included, so it is exclusive, and the step value is 2. So 1 plus 2 is 3. So that is the reason you are having the output 3. Understand this. First is 1, so you're printing that num. And the second, or the first, let's do this. The values or the possible values of this range function are 1, 3, 5, 7, 9. Because 9 plus 2 is 11. 11 is outside our range. So we are only stopping until 9. So when you are printing for num in range 1, 10, 2, the first iteration, the num value will be 1 because that is the starting limit. Second iteration, num value will be 3 because the step value is 2. So 1 plus 2 is 3. You are printing the 3 number. Next, 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. You can also have negative as your step values as well. So you can also have -2 or -1 as your step value. There are some examples where you'll be working with negative step values, and also you can have negative ending limits. But you also have to make sure that if your ending limit should always be greater than your starting limit. If it is the opposite, then the loop will not execute because the starting limit is less than the ending limit. It doesn't know where to go next. So we always use the target variable inside the loop, right? So for now, we have only used that to print. For example, here, we are not even doing anything. We are just printing hello world. But in this case, you are using the target variable num, and you are just using that to print. But there are many other examples where you can, make certain calculations by using the target variables. So for example, is calculating the square root of each of the number in the range function. So let's take a look at this example. First, you have a start, next the table headings. Is there another value in the list, which is also known as a sequence? You will be introduced to lists in chapter 7. But for now, just understand that the range function will return a sequence of digits. So is there another value in the list? If it is yes, assign that to the next value in the list to a number, and then you're using square is equal to number times 2, that is exponent 2, displaying the number. You're checking again, otherwise if there are no more digits, you're just coming out of the loop. So take a look at this for loop here. For number in range 1, 11. So your starting number is 1, your ending number is 11. But the table or the program is supposed to print all the numbers and its squares from numbers 1 through 10. As 10 is the number that we want, or this program is asking you to print the table with till number 10, you are adding plus 1, because 10, if you just have it as 10 here, then the list of elements in the range function will only be till 9. Right? Because ending limit is not inclusive. That is the reason you should have plus 1. You should add plus 1 whenever you are working with 2 arguments if you want the second argument to be included. So now what are the possible list of elements that you can expect from this range function? Just range 1, 11. That is range 1, that is square brackets, which is a list 1, 2, 3, 4, 5, so on and until 10. Right? So for the first iteration, number will be 1. Next, you are assigning a variable that is square is equal to number exponent 2. You are printing number square. Notice \t will give us a tab space. We already know that from special characters in chapter 2, I guess. Next iteration, number will be 2. Next 3, next 4, and so on till 10. So you can also let the user control the total number of loop iterations. So till now, you have only seen where the program has decided for the total number of repetitions, like it has decided that the numbers can be from 1 through 10. But what if you want to ask the user to enter the starting limit and the ending limit? So you can receive the inputs like through the variables, and you can assign those variables as arguments inside our range functions. So say this. Case number is number from 1 to user given n number. So you're basically, this displays a list of numbers starting at 1 and their squares. So you're basically taking the previous program, but instead of us deciding the ending limit, you are asking the user to enter the ending limit. So int end is equal to int input, how high should I go? Let's say the user has entered 5. As we don't know the exact number the user will be entering, you are just going to take this variable and add 1 in as your ending limit inside your range function. So for num in range 1, and plus 1. If the user has entered 5, so the user will be expecting to see the numbers and its squares from 1, 2, 3, 4, and 5, right? Because the user wants to see from the numbers 1 to 5. So if you do not have a plus 1 here, then the user will only be seeing till 4, because 5 is not inclusive, which is not included because it is our second argument. So that is the reason you should make sure that you are adding plus 1. And the second case is where the user is giving the first and the ending limit and the starting limit as well. So you're getting the starting limit, start, you're getting the ending limit, start, and plus 1. So you are getting the starting limit, you are substituting that starting limit here. Next, ending limit plus 1. That will give you, say, exam execution. So for the range function, you can also use the range function to display like numbers in ascending or descending order. When you are trying to display the numbers from ascending order, you could just do that by using single argument. So range 5. So that will give you the numbers from 0, 1, 2, 3, 4, which are in the ascending order. But if you want to see the numbers in descending order, then you can use negative step values. So as you are starting from a bigger number and going to the lower number. It is 10 minus 1, 9 minus 1, 8 minus 1, 7, so on and so forth till 1, because 0 again is not included. Okay, so in the next lecture, we'll be talking about accumulator value, or maybe let's just do that here as well. Okay, so if you are calculating a sum of a series of numbers, then in that case you will be using the concept of running total, which is basically where you will be introducing the accumulator variable. So accumulator variable, like when you're writing or when you're working on your program, there is no special syntax for accumulator variable. It is just ACC or accumulator or sum or add, anything that you want. But that variable is called as accumulator variable because it is holding the sum of all the numbers in that series. Okay. Let's see. So first, when you are using the accumulator variable, you must assign that to 0. This is because if you do not assign that to 0, then there is a good chance of having garbage values assigned to that accumulator. So basically garbage in, garbage out from chapter 1. So the program or the interpreter will itself, there are chances of providing or assigning garbage values to the variables which are not defined. So that is the reason we are first setting the accumulator to 0. Next, you are reading another number in the series. If there is a number, then you are adding that number to your accumulator. You are checking again. If there is another number, you are adding that to your new accumulator number. So let's say you are adding the numbers from 0 through 5. So first number is 0. You are reading that number. You are adding that to your accumulator, which is also 0. So the accumulator is now 0. Next is 1. So when that 1 is added to the accumulator, which is 0, it will be 0 plus 1. So the accumulator is now 1. Next number in the series is 2. So the 2 will be added to number 1, which is our accumulator. So so now the updated accumulator value is 3. Next, so on and so forth. So at the end of the loop execution, the accumulator will have the total number of, like the sum of all the numbers in that series. So you can also define that as accumulator is equal to accumulator plus number. In the next lecture, we'll also see about augmented assignment operators and how can we use augmented assignment operators. So for now, let's just understand loops until this lecture.